Alright, so for this problem, Physics 184, still in Chapter 28, this problem 9, power resistors, we're given that the 10 ohm resistor in the figure right here is dissipating 50 watts of power, which I wrote out. And the question is, how much power is the 5 ohm resistor dissipating, which is the resistor right above this one. So with all these resistor problems, I like to refer to this table, so the current in series remain the same, the current in parallel, you just add them. The voltage in series you add, and the voltage in parallel they remain the same. So that's what I'm gonna try to do first. Try to figure out what's going on here. So basically given the power, right? So that's gonna be 50 watts. We don't know the voltage, but we do know the resistance, right? So we can also write this as E is equal to that's like the voltage is equal to negative IR. That way we know the resistance, right? So if we just start to fill in stuff that we know, right? So let's just say, we're really just trying to find I here. We know that if we try to plug it in, we have 10 for the I, or for the R. And for this top equation, we have the power. Right? So we can try to solve for I, as these are both unknowns. This is also the same as V. So if we did that, we will get 50 over I10. I mean, I'm not going to worry about this negative sign since we're just going to look at the absolute value of everything. So we got I squared divided by 50 divided by 10, which is just 5. So the square root of 5 is going to be 2.24 amps. So if that is 2.24 amps, we just want to know what the how much power this is dissipating. So we rearrange this out for PR, and this is going to be I times the voltage. We don't know the voltage right here at this point, but we do know that this one is going to be 2.2. If I could draw it up properly. Okay, I guess I can't read. Okay, 2.24 amps. And we do know that the voltage is just going to be equal to negative V and or negative IR. So if we plug in our current, which is, again, let's get rid of, we're just going to worry about the absolute value of everything. If you see me erasing the negative signs, times the resistance, which is 5. So typing this in my calculator, I get the voltage of 11.18 volts. So the power is going to be equal to 2.24 times 11.18 volts. That's amps right there. Type this in calculator, I get 24.999 repeating, or really 25 V volt times amps, which is also equivalent to watts. So 25 watts. And here you guys can see on the Mastering Physics website, that's exactly what they got here. Second question, it's asking how much power is a 20 ohm resistor dissipating. So let's go ahead and write these in series. If we were to redraw this out, or in parallel, not in series, you'll just get one like that, right? So if we know that if we add these up, remember I told you guys that these two are just if they're in parallel, you can just add them up. So if we add up the current, that's just going to be 4 amps, and then the if they're in series, the resistance, you're just going to have to add them. On the resistors, you just add them up, so that's just going to be 15 ohms. This one's 20 ohms. So we have to find the power again. So the power equation is going to be I times V. So how do we find this one? Well, first of all, we can find, because we know that in parallel they're the same voltage. So we have to find the voltage. So again, equals IR. Let's go and multiply 15 by 4.47. That's going to give us 67 volts. It's also 67 volts. So we're just going to get 67 times. Oops, that's not correct here. We're going to find the current. So I is equal to E divided by R. So that's just going to be 67 divided by R, which is just 20. So 67 divided by 20, it's going to be 3.5 amps, and we have to multiply that by the V, which is times 67. There's 224, which is not correct. Must have made a mistake here. Let's go ahead and take a look at this problem. Okay, so series. Oh, that's my biggest problem right here. See, if they're in series, I misread the problem, guys. If they're in series, they're the same. You don't add them. You guys are probably saying, "What? You don't add them?" But you see, I don't even have the table memorized yet, so it's so it's really just 2.24. I was thinking that voltage is a little big. 67 volt. That's a big voltage, right? So that's still the same right there. So again, we can get it by IR. So 2.24 times 15. All right, now we got 33.6 volts, which is looking better. And okay, if they're in parallel, they're the same. So I is equal to, on this one, that's just going to be divided by R. So we're just going to divide the 33.6 by 20. We get 1.68 amps. So the power, right, this is going to be 1.68. Looking at this equation right here, 1.68 times 33.6, which is going to get us 56.4, which is just, as you guys can see in the answers, it's going to be 56 watts. And that's it.